Hello and welcome to 8.1 Basic Integration Rules. Okay, example 1. Select the basic integration formula you can use to find the integral and identify u and a when appropriate. Okay? So if you look in your textbook on page A21, that's in the appendix, there is a big long list, like 4 or 5 pages worth of integration tables. Here are the integration tables on page A21, and you can go through all these. Like I said, there are several pages of them. Take a look. And this is the one that's on WebAssign. Here, turning pages, and so on. So you can look at those. But the point is, we want to look at this and determine which would be the appropriate formula for what we're doing. Let me go back to our problem. Problem is 3x minus 2 to the 4th power. So what should we do with this? If you look at the first one is integral of u to the n. And this is something that you're all, I'm sure, very familiar with. Here it is. U to the n du is u to the n plus 1 over n plus 1 plus c. That's the one we're going to use here. Where our u is going to be that 3x minus 2. Nope. There. Okay. So if we say we're using the page A21, number 1, the integral of u to the n du is u to the n plus 1 over n plus 1 plus c. So I'm going to say u is 3x minus 2, so du is 3dx, and 1/3 du equals dx. This becomes 1/3 integral of u to the 4th du is 1/3 u to the 5th over 5 plus c, or 3x minus 2 to the 5th power over 15 plus c. That's it. Using that number 1. Let's go on to the next one. Now this next one, you want to pause and take a look in the book and see if you could find it. Otherwise, it's right here. 1 over u, we're going to go with this formula here. Number 2 from the integration tables. Integral of 1 over u du equals the natural log of the absolute value of u plus c. So in that, we'll say that our u is t squared minus t plus 2. So du equals 2t minus 1. Hey, we have a 2t minus 1. This is going to be the integral of 1 over u du, natural log of the absolute value of u plus c, which is natural log of the absolute value of t squared minus t plus 2 plus c. So I'm not going to keep switching back and forth, but referencing the book, please use that in here. Let's go on to example 2. Select the basic basic integration formula you can use to find the integral and identify u and a when appropriate. So in this case, what if we said u equals 2t minus 1? Our du would be 2 dt. This would become, so 1/2 du is going to be dt. Well, actually, I do have a 2 dt. Okay, I don't need to make that division happen. So we have the integral of 1 over u squared plus 4 du. So which formula would this be? You might remember this from last semester. Looks a lot like an arctan to me. So I'm using formula number 23, which says the integral of 1 over a squared plus u squared du is going to be 1 over a arctan of u over a plus c. Now my a squared is 4, so a must be 2. We're talking 1/2 arctan of u over 2 plus c, which is going to be 1/2 arctan of 2t minus 1 over 2 plus c. Feel free to pause that. I'm going to scroll on here. I'm going to find the indefinite integral now of t squared minus 3 over negative t cubed plus 9t plus 1 dt. Sometimes it's helpful just to look and see what you have. If we said u equals negative t cubed plus 9t plus 1, du is going to be negative 3t squared plus 9 dt. We don't quite have that, but this is a multiple of the numerator. We could divide by negative 3, and negative 1/3 du is equal to positive then, t squared minus 3 dt. So this becomes negative 1/3 integral 1 over u du, which is negative 1/3 natural log of the absolute value of u plus c, which is negative 1/3 natural log of the absolute value of negative t cubed plus 9t plus 1 plus c. That's that. Okay, for example 4, find the indefinite integral with the integral of 2x over x minus 4. When you have this situation where you have the same power on top and bottom, or maybe it's a bigger power on top than bottom, try some long division. Now you could use numbers 21 and then number 3. I'm going to do the long division. X minus 4 goes into 2x plus 0. X times what is 2x? It's 2. So you have 2x minus 8, subtracting, you get 8. So this becomes integral of 2 plus 8 over x minus 4 dx. That'll be the integral of 2 dx plus 8 times the integral of 1 over x minus 4 dx. So you can have 2x plus 8 times the natural log of the absolute value of x minus 4 plus c. Okay. I'm going to go on to example 5 now. Find the indefinite integral. We have integral of 5 over 3 to the ex minus 2 dx. We might need to manipulate things once in a while. Think of this as 5 over 3 e to the x minus 2, and multiply by e to the negative x over e to the negative x. This will be integral of 5 e to the negative x over 3 e to the negative x times, no, e to the x times e to the negative x, minus 2 e to the negative x, dx. And you can pull the 5 out. 5 times the integral of e to the negative x over 3 minus 2e to the negative x dx. So if we said now u equals 3 minus 2e to the negative x, the problem we had initially, we had an e to the x down below, but no other e to the x. So if we made that the u, no e to the x to the du. But now we do have an e to the x in the numerator. Our du would be 2e to the negative x dx. So we can say 1/2 du equals e to the negative x dx. And we can make a substitution. So we'd have 5 times the 1/2 integral 1 over u du. That's 5/2 times the natural log of the absolute value of u plus c. Or 5/2 times the natural log of the absolute value of 3 minus 2e to the negative x plus c. Okay, so again, we made this u, our du is going to be 3e to the x. No 3e to the x up there, or 3 to the x dx. Don't have that. By multiplying by e to the negative x over e to the negative x, that allows us to have an e to the negative x on top, e to the negative x in the bottom. This becomes the u. This is part of the du. And you have a natural log. Let's go on to the last page here. Now we're going to do some trigonometry, which is always a crowd pleaser, right? Okay, we have integral of 1 plus sine x over cosine x dx. Now we know that sine and cosine have a relationship, that sine squared x plus cosine squared x equals 1, which results in cosine squared x equals 1 minus sine squared x, and sine squared x equals 1 minus cosine squared x. We know we have that relationship. So when I see a 1 plus sine x, it starts me thinking this is related to the cosine. If I treat this as integral of 1 plus sine x over cosine x and multiply by the conjugate of the numerator, we'll have 1 minus sine squared x over cosine x times 1 minus sine x. That's going to be a cosine squared x over cosine x times 1 minus sine x. Now the cool thing here is I can reduce those cosines and have the integral of cosine of x over 1 minus sine x dx. So if we say u equals 1 minus sine x, du is going to be negative cosine x dx. So negative du equals cosine x dx. We end up with negative integral 1 over u du, which is negative natural log of the absolute value of u plus c. Again, negative natural log of the absolute value of 1 minus sine x plus c. That's it. Now we could have gone a different way with this, done 1 over cosine x, but that's going to be, that'll be like a secant, not like, that'll be an integral of secant, and then sine over cosine is going to be a tangent. So it'll end up being a secant x plus a tangent x. That could be a lot messier. And often to deal with issues with trigonometry, we go back to sine and cosine. Makes it a little simpler. Okay. Let me scroll this up. Now we have integral of 1 over 4 plus 3x squared dx. We'll try different things for u, but if we say u equals 3x squared, I'm sorry, u squared is 3x squared. That means u equals the square root of 3 times x. The idea is if we have something squared plus something squared, we can take advantage of an arctangent. So, I mean, as it sits, you could treat this as 2 squared plus square root of 3 times x squared. You can use the arctangent. Okay, and our a squared is 4, so a is 2. So from page A22, use number 23. The integral of 1 over a squared plus u squared is going to be 1 over a arctangent of u over a plus c. So our u is square root of 3 times x, and our a is 2. This becomes, now I should say, 1 over the square root of 3 times u equals x. So we have the 1 over the square root of 3 du equals dx. So we have 1 over the square root of 3 integral 1 over 2 squared plus u squared du. So it's 1 over the square root of 3 times 1 over 2 arctangent of u over 2 plus c. So it's 1 over 2 times the square root of 3 arctangent of, what's u? U is square root of 3 times x over 2 plus c. And if you want to rationalize the denominator here, you can. Okay, we're down to our last problem of this section. It says evaluate the definite integral. Use the integration capabilities of a graphing utility to verify your results. Now with this, you can separate this up. This becomes the integral of x over x minus 2 over x from 1 to 2 dx, which is the integral of 1 minus 2 over x from 1 to 2 dx. If you integrate that, you're going to have x minus 2 natural log of the absolute value of x from 1 to 2. That's going to be 2 minus 2 natural log of 2 minus 1 minus 2 natural log of 1. Well, we all know natural log of 1 is 0. So you end up with 2 minus, you can bring this 2 as a power, natural log of 2 squared minus 1, or 1 minus natural log of 4. Okay. If you want the decimal on that, that's going to be approximately negative 0.386629. Okay. That's it for 8.1, basic integration rules. Okay, I'll see you guys later.